Welcome to Scholarlink Online Tutors, episode Physics. Physics is a branch of science that deals with the study of matter and energy along with their relationships, which means that in this branch we study about the fundamental science because it deals with the most basic principles that govern the universe. Yeah, it's true, because of the fact that physics provide a detailed knowledge and information about all the theories, all the facts and knowledge of the universe. It's not about just the Earth, it covers the whole universe. From why objects fall to ground to how light travels through space, physics seeks to explain the laws that shape reality. Because it indulges, the physics is divided into many subfields, such as mechanics, thermodynamics, electromagnetism, and quantum physics. Each of the areas explores a specific set of rules that control how matter and energy behave. It is a vast field. Now we'll consider the brief history of physics. Humankind's understanding of physics has evolved over thousands of years. Early Greek philosophers like Aristotle tried to explain the natural world, but it wasn't until the work of Galileo and Isaac Newton in the 17th century that modern physics was born. It was because of the efforts of these two scientists that we are now exploring the wonders of nature. Galileo's experiment with motion and Newton's formulation of laws of motion and gravity changed how we view the universe. By their experiments, by their work, their efforts, now we are able to uncover the mysteries. And later in the 20th century, Albert Einstein's theory of relativity and the development of quantum mechanics further transformed our understanding of the cosmos, the detailed world of the cosmos. It was a great achievement, and Albert Einstein is a well-known scientist. His publications are all famous over. Now consider the laws of motion and gravity. The first law states that an object at rest always remains at rest, and an object in the motion stays in the motion unless acted upon by a force. Hence, the second law tells us that force equals mass times acceleration. You can say that F is equals to m times acceleration, or A, which is force is dependent on the mass of the object or the body and along with its acceleration. And the third law is very detailed and comprehended, though it has very short words, that for every action there is an equal and opposite reaction. Yeah, it's true. It's universally accepted that for every kind of reaction, there is always an equal and opposite reaction for that. Because, for example, if you're pushing a pendulum to the right side, it will move to the left, even though apart from its mean position, it will move to another extreme position, and then it will move back and swing. You can see with the illustrations of the diagram given in the tray. It's a very easy thing, and it's very universally concepted like phenomena. And the third law, which is of course variable on every kind of phenomenon. Again repeating, for every action there is an equal and always opposite reaction. So Newton has formulated the law of gravitational, universal gravitation, which explains how every mass in the universe attracts every other mass. This law is why we stay anchored to the Earth and why planets orbit around the stars. This is the main reason, because gravitation, it is a very important perspective, and you can say a unique characteristic of the Earth, that the gravitational force acts within certain limitations and boundaries of the Earth. That is the reason that while Newton was judging that the apple didn't just go away upward, when it fell, it moves downwards, not upwards. Why is it moving downward? Because of the force of gravitation. Yeah, it's the gravitation that is responsible for all these ongoing actions. It is the property of the Earth that is indulging, that is attracting the things toward itself. It is wonderful. It's wonderful to know that everything is doing the same way. Now let's see something about energy in thermodynamics. Another key area of physics is energy. Energy comes in many forms, such as kinetic and all that stuff. Thermodynamics, it is a branch of physics that studies how heat and energy work. The first law of thermodynamics tells us that the total energy in the system is always constant. The second law, however, introduces the concept of entropy, essentially the idea that systems naturally move towards disorder. Entropy is a concept that tells you that every system in the universe, it is moving towards disorder from order, and this is known as entropy. Now, electromagnetism and light, what is this thing? One of the most fascinating areas of physics is electromagnetism. It's the study of electric charges, magnetic fields, and how they interact together. And light, for example, it's part of the electromagnetic spectrum, which also includes radio waves, microwaves, X-rays, and more. Understanding electromagnetism is very important. And the most tantalizing and interesting, quantum physics. While classical physics helps us understand everyday objects and forces, quantum physics takes us into the strange world of the very small particles that make up atoms. In quantum physics, particles can exist in multiple states at once, and the behavior seems to defy our everyday understanding of realities. Quantum mechanics has given rise to technologies like semiconductors, lasers, and even quantum computing, which has the potential to revolutionize your future. And all the gadgets, the systems like lasers and others that you are using in advanced fields in today's life, they are the result of the quantum mechanics field. It's undoubtedly one of the most interesting parts. Now, concluding today's episode in just a nutshell, the physics is the foundation upon which many other sciences are built. It helps us understand the force of nature, the behavior of matter, and much more. So stay tuned for the upcoming videos only on Scholarlink Online Tutors, your first destination to learn each and every step in a unique way. Thank you so much.